In this video, we're going to talk a little bit more about the GCF and LCM and just a few little tips. In the previous videos, we broke down and handled and looked at them one at a time, the GCF and the LCM. And what happens a lot of times for students is once we put them together, they have a little bit of difficulty remembering, which one's which. Which one do I want the larger power of the variable to appear in? And which one do I want the smaller power of the variable to appear in? And so here's my little tip or hint. Let the numbers be your guide. You're going to find the GCF and LCM for the numbers. Most likely, most of you are going to find that using your calculator. So if you look at that number, okay, say you find the number for the GCF, you'll notice that it is smaller than the numbers in the original monomials. And that's your clue that you want the smaller powers of the variables in your GCF. And if you find your LCM on your calculator, you'll notice that the number is larger than the numbers in your original monomials. And hopefully that'll be a hint that you want the powers of the variables that are the largest. Okay, so that's a little connection that I hope you can make that'll help you remember what piece you want for each. So for these problems, we're going to find both the GCF and the LCM. We'll start with the first one, 4x to the third y squared and 10x squared y to the fifth. First, I'm going to go ahead and find my numerical portion of my GCF. And so I want to take that for 4 and 10. And I get that the numerical portion is 2. That's smaller than the numbers. That should be my reminder. Take the smaller power of the variables. I've got an x to the third and an x squared. I want the smaller power. That's x squared. I look at the y's. Got y squared and y to the fifth. I want the smaller power. That's y to the second. So there's my GCF. And my LCM. I'm going to go ahead and find that, the numerical portion on my calculator. Command 8. LCM for 4 and 10. And that's 20. And 20 is bigger than both of the numbers in our original, which should remind us that we want the bigger power of the variables. So we've got x to the third and x squared. We want the bigger. That's x to the third. And we've got y squared and y to the fifth. We want the bigger. That's y to the fifth. And there's our GCF and our LCM in part A. Let's go ahead and do the same thing in part B. We're going to find the GCF and the LCM. Start with the numbers. Go over to our number command. And we get the GCF for 12, 20. It's 4. Smaller than the numbers. A reminder, we want the smaller power of the variables. Look at our x's. We've got x to the 8th and x to the 4th. The smaller of those powers is x to the 4th. We've got y to the 5th and y to the 7th. The smaller of those powers is y to the 5th. And we've got z to the 4th and z to the 6th. The smaller of those powers is z to the 4th. And there's my GCF. Now my LCM. Go ahead and find the numerical portion. Calculator. 60. And now 60 is bigger than the two numbers to remind me that I want the larger power of the variables. So x to the 8th and x to the 4th. The bigger one is x to the 8th. Y to the 5th and y to the 7th. The bigger power is y to the 7th. And z to the 4th and z to the 6th. The bigger power is z to the 6th. And by the way, a little side note that I think it's something that everybody should kind of understand about GCFs and LCMs is when you take the GCF and the LCM for two monomials like this, if you multiply the GCF and the LCM together, you should get the same thing you get when you multiply the two original monomials together. For instance, the numerical portion 4 times 10 is 40. The numerical portion of the GCF and the LCM, 2 times 20, is also 40. Okay? If you look at the variable portions, the originals, x to the third and x to the second, if you multiply those together, you get x to the fifth. Same thing if you multiply the variable portions of them together. That's a nifty little thing to know, that the product of the GCF and the LCM is the same as the product of the numbers. And you see the same thing if I do the numbers from the original in part B, 12 times 20 is 240, and the product of the numbers from the GCF and LCM, same thing, 240. Just an interesting little tidbit that I think everybody should kind of know in the back of their heads about GCFs and LCMs. All right. Next, we're going to look at finding GCF and LCM with more than 2 monomials. Now, the idea is the same. We want the biggest number for the GCF. We want the biggest number, biggest power of the variable that divides evenly into all of these monomials. And we're going to handle it in much the same way. We're going to first find the greatest common factor, the numerical portion on our calculator, and then we're going to deal with the variables as well. So we'll go ahead and start. I'll use my GCF command. I'm going to intentionally make a mistake here. We want the GCF of 12 and 8 and 20, and if I try and find the GCD for all 3 of those numbers at once, my calculator is going to get very mad at me. It's going to give me an error, an argument error, and if I go to that error, it's telling me there's something wrong with what I've typed in. And what's wrong with what I've typed in is the GCD command on the calculator only handles 2 numbers at a time. So we can't just type in all 3 numbers at once. The way we need to approach this is we need to take the first 2 of the 3 numbers and find the GCD of those 2. And then we need to find the GCD of that number, whatever we got first, which was 4, and the third number in our list. We already did it for 12 and 8, so now we need to add the 20 in there, and we need the GCD for those 2 numbers, and that's going to be 4. And so 4 is going to be the numerical portion of my GCF, and my variable portion, 4 is smaller than all the numbers. Reminds me I want the smallest power of x. Got x to the third, x to the fifth, x to the sixth. The smallest of those 3 powers is x to the third. Do the same thing with y's. Got y to the 8th, y to the 4th, y to the 6th. The smallest of those 3 powers is y to the 4th. And now I'll go ahead and find the LCM. I'm going to attack it the same way for the numerical portion on the calculator. I also need to do 2 at a time here, so I'm going to find the LCM of 12 and 8. That's 24. And then I want to find the LCM of that and the third numerical portion in our list. And that's going to be 120. All right, and now that's bigger than all the numbers in our list. And so I want the biggest power of the variables. I've got x to the third, x to the fifth, x to the sixth. X to the sixth is the biggest of those. And I've got y to the 8th, y to the 4th, y to the 6th, y to the 8th is the biggest of those. There's my GCF and my LCM. Do that again for part B. First, I'm going to start with the numerical portion. GCD of 25 and 15. It's 5. And GCD of 5. And the third number in the list, GCF here is going to have a numerical portion of 5. And then I want the smallest power of each variable that appears. Let's see, I've got an x to the third, an x to the 8th, and an x to the 5th. The smallest of those is x to the third. Let's see, I've got a y squared in the 1, but I don't have any y's in any of the others. So the smallest power of y that appears is actually y to the 0, or no y's in the expression. And so I'm going to have no y's in my GCF. If I look at my z's, I've got a z to the second. Oh, there's no z in the second one, so there's going to be no z's in my GCF. And so I'm finished with my GCF. It's 5x to the third. And then my LCM, I'll go ahead and do the numerical portion. LCM of 25 and 15. And then the LCM of that and 45. 225 is our numerical portion. And now we want the biggest power of the variables that appears in any of these. So we've got x to the third, x to the 8th, x to the 5th. The biggest of those is x to the 8th. We've got no y. We've got a y squared, and we've got no y. The biggest power of y that appears in these is y to the second. And then z's, I've got a z squared, no z, and then a z to the first. The biggest power of z that appears is z squared. And that concludes this video on more with GCF and LCM.